All right, hi guys. We are now going to go to lesson 1, session 1, and it's on page 5. So go and open your books and get to page 5. Before we just dive right into this lesson, I want to do a quick little review. Hopefully it's a review. I want to talk about the 3 types of triangles. So we know a triangle has 3 sides, 3 angles, 3 corners, whatever. That's pretty easy, right? But there's 3 types of triangles. There is an equilateral triangle. Here, let me go and write this down. Oops. Equilateral. There's an isosceles. And then there's a scalene. Okay, so there's 3 types of triangles. An equilateral triangle are the easiest ones to remember because all the sides are equal. Bear with me on my drawing here. If I were to say that this was 2 inches, this was 2 inches, and this was 2 inches, that is an equilateral triangle. An isosceles triangle, this one's easy to remember because it's isosceles, ice cream cone. Looks like an ice cream cone. So, oops, that was kind of a bad drawing. Let me redo that. The thing about ice cream cones is they got 2 sides that are the same. So if I told you that this was 3, this would be 3, and let's say this is 2. So isosceles triangles have 2 sides that are the same, 1 that is not. The last one is scalene. Scalene are the weirdos who have no sides the same length. So if I told you this was a 1 and this was a 2, this would be a 3. Okay, so we have equilateral, means all things are equal, all sides are equal. Isosceles means that there's 2 sides the same, like an ice cream cone. And scalene are the weirdos where they have nothing the same. Okay, let's go back to the lesson. We're on page 5. We're going to explore some triangles in these scale drawings. Previously, we learned about ratios and rates. In this lesson, we're going to learn about scale drawings. We're going to use what we know to try to solve the problem below. So here's a really cool dome, and it looks like this dome is made out of a bunch of different triangles. Okay? A geodesic dome is a dome made of triangles. To make a model of a geodesic dome, Anya needs a smaller triangle that is the same shape as triangle A. Which of these triangles could she use? Tell me how you know. Okay, so let's look at triangle A. Triangle A has a side that is 10 feet long, another side that is 10 feet long, and one side that is 12 feet. What kind of a triangle is that? Reverting back to the 3 that I just taught you. If you're telling me that that's an isosceles triangle, you are perfectly correct, because there are 2 sides the same length, one that is not. Now let's go look at B, C, and D. B has all sides are 1.2 centimeters. Can't be B. C has one side that is 1.2, one side that is 1.2, and then one side that is 1. Now, that is an isosceles triangle, is it not? I mean, it's perfect, right? You could put a little ice cream cone right there. It's a little upside down, but that's definitely an isosceles triangle. But we always check the rest. Let's look at D. D's got one side that's 1, one side that's 1, and one side that's 1.2. Well, you guys, that's also an isosceles triangle. So if you're thinking to yourself, wait, there's 2 isosceles triangles, can't it be C or D? Some kids will look at the picture. Let me go and erase some of my markings right here. Some kids will look at the picture and say, well, it can't be C. And the reason why I think that is because C looks a little bit steeper. And what I mean by that is like the triangle over here, A, he looks kind of like fat, right? Like if I had this as an ice cream cone, like it'd be like ice cream cone, right? Whereas this guy is kind of steep, like the cone is kind of more angled. Whereas D is kind of like that flat triangle. So if you're thinking that way, I feel like that's a great way to just like look at it and get an idea of what the answer could be. You're not wrong if you say that D is the correct triangle because it looks the same as A. You're not wrong, and I think that that's a pretty good answer. So let's go ahead and put that down. Let's say first I saw that triangle C and D were both isosceles triangles. However, triangle D is the same shape as A. Okay, so that's a good beginning to your answer. I mean, it's not the whole answer, but I feel like that's a good beginning because it really does look like the same triangle. Let's talk about those numbers though, the numbers that are next to the sides. If we look at triangle A, we can see that one side is 10, the other side is 10, and the other one is 12. I like to think of these as proportions, okay? Let's call this side A, and this side B, and this is side C, okay? If I were to make a proportion, I said A is to C. Now if I go over here to my isosceles triangles, C and D, let's make a little proportion to these. So let's say this is A, this is B, and this is C. Same thing. This is A, this is B, and this is C. Let's make a little proportion with this. So back over here, we have A is to C. What is A? A is 10 feet. I'm gonna write it over here. A is 10 feet. What is C? C is 12 feet. Okay, I'm gonna set them equal to each other. Now what that does is that shows me that if these are equal to each other, then they are proportional. And we want them to be proportional. So let's see, we have, let's do triangle C first. A is to C. So that would be 1.2 over 1. Now I know what you're thinking so far, like this does not look correct. This looks so weird. Now, can I reduce 10 over 12? Yes, I can. I can take out a 2 for each of those. So I could get 5 over 6. Can I reduce anything else? No. Is 5, 6 equal to 1.2 over 1? Which isn't 1.2 over 1 literally just 1.2? What is 5 divided by 6? Because remember, a fraction just means divide, right? What is 5 divided by 6? 6 can go into 5 0 times. Give me a decimal. Add another 0. 6 can go into 50. Oh gosh, let's see. How about 6 times? What's 6 times 8? It's 48. It's probably as close as we're going to get. 6 times 8 went on a date, then they came back with 48. Subtract those out. 2. Okay, I'm going to add another 0. How many times can 6 go into 20? Let's see here. 6 times 5 is 30, so we need to go lower than that. 6 times 4 is 24. 6 times 3 is 18. That's as close as we're going to get. We get a 2. Looks like this problem is going to go on literally forever, so it's 3 repeating. Okay, the reason why we just did all of that long division is because I just wanted to take 5 divided by 6. 5 divided by 6 equals 0.83 that repeats. Is 0.83 Is this equal to this? No, definitely not. Okay, so I'm not going to erase all my work because I don't want to, you know, make it look like I didn't do anything. But here's what I'm going to write up in my description. I'm going to say C is not proportional, to triangle A. I know this because now this is where I'm going to write down 0.83 with a hat is not equal to 1.2. So yeah, I'm going to erase my work a little bit just so I can fit some more stuff in here. Is not equal to 1.2. Okay. Period. Triangle D, I'm going to say it is proportional, but then we'll go check and make sure it is. Because, okay, so remember what we did? We made a fraction called a proportion. We took A over C, which was 10 over 12. I'm going to use a different color for you guys. 10 over 12. And then we're going to take A over C, 1.0 over 1.2. Okay. I wonder if you guys know this. There's this super cool rule that says if you do it to the top, you got to do it to the bottom. If I want to move this decimal over one place to the right, I can, as long as I do it to the bottom. Okay, so if I move the decimal over to the right one, what do I now have? I now have 10 over 1.2. Oops. I meant 10 over 12. Is 10 over 12 equal to 10 over 12? Yes. Okay, so we just proved it. I'm going to erase this so I have some room. Triangle D is proportional because 10 over 12 is equal to 10 over 12. Or you could say 1.0 and 1.2. Period. Okay, now when we do problems like this, this is the kind of effort that I am looking for. I am looking for complete sentences. I am looking for your work. I know it's hard, like I had to erase my work to be able to finish writing my sentences, and I completely understand if that happens, which is why I have scrap paper for you. But this is the answers that I am looking for. Okay, I am not looking for a number. I am not looking for a yes or a no. I'm not wanting you just to say triangle D. I know this because I do. I am looking for all of this, okay? This is the standard that you have to be held to. And as we go through the chapters, you're going to get better and better and better at it. Okay, let's go to the next page. Okay. Connect it. Look back. Which of the triangles could be the same shape as triangle A? Explain. Okay, so if we go back here, which of these triangles could be the same shape? I mean, obviously, it's D, right? D is the same shape as A because C is C is just too angled. Would you guys agree with that? So that's what we're going to say. It's not a trick question. We're going to say triangle D is the same shape as triangle A, period. Now, don't forget this. Look at that. Explain! You can't just give me an answer and then not back yourself up. Triangle D is the same shape as triangle A. Triangle C is isosceles. But, oops. it is, I'm going to say it's like too angled. Like, you know what I mean? It's not the same angle. And it is not the same shape. All right, look ahead. Triangle D is a scale drawing of triangle A. A scale drawing of a figure is a larger or smaller than the original figure, but it has the exact same shape. The scale is the ratio between the side lengths. Remember, we did that over here with our little fraction guy? Okay, so to make a scale drawing of a figure, you can multiply each length of the original figure by a scale factor. The scale factor is what you're multiplying the sides by to get there. So, for example, see triangle ABC, and then see triangle DEF. Could the scale from those two triangles be 1 to 3? Well, let's find out what the scale factor is first. Remember, the scale factor is like what you multiplied one side to get to the other. I always like to start with the smaller ones if I can. So from A to B, what did I multiply 1 centimeter by to get the corresponding side, which is DE, 3. 1 times 3 is 3. How about B to C? What did I multiply 2 by to get to 6? It should be the same number. And it is. 2 times 3 is 6. Now we have 2.5 and we have x. It's unknown. But we can easily find out what x is because we just need to take 2.5 and times it by 3. 5 times 3 is 15. 3 times 2 is 6, plus 1 more is 7. This decimal is over 1 space, so we move our decimal over 1 space. 7.5. Now I'm definitely getting ahead of myself here because I'm pretty sure C is asking us to find x, but that's okay. So why could the scale be 1 to 3? Remember how I said that we could also write them as fractions? Could I compare this side? Oops, here, let me get my laser pointer. Could I compare this side to this side? I could. And I could also write them as a fraction. I could say 1 over 3. Or I could write them as a ratio 1 to 3. So it says explain why the scale from that triangle to that triangle could be 1 to 3. Here's what we're going to say. We're going to say AB with a line over it, that means side. Side AB and side DE are corresponding sides. Okay, that's all we're going to say. They're corresponding sides. Explain why the scale factor from ABC to DEF is 3. Well, we found that out because we know A to B equals 1 and DE equals 3. 1 times 3 equals 3. Okay? So we can just use that as our explanation. That's how we figured it out. You could also throw in there that we know that BC is equal to 2 and EF is equal to 6, and we know 2 times 3 equals 6. What is the value of x? Describe 2 different ways you could find it. Okay, so x equals 7.5 centimeters. Okay, 2 different ways that we can find it. I'm going to say that I used the scale factor Remember, the scale factor is what you can multiply each of the sides and get that bigger triangle. I used the scale factor of 3 and multiplied it by 2.5. Okay, I'm not going to give you another way because I feel like this video is getting long, and so you can just give me one way as well. Number 3, reflect. Yukio says the scale from triangle DEF to ABC is 3:1. Is he correct? Okay, so we said the scale from ABC to DEF was 1:3. So remember, that means we went from this triangle to this triangle. Okay, 1, 2, 3. Yukio is saying if I flip it and say DEF to ABC, he's saying it's going to be 3:1. 3:1. Is he correct? And that is a big fat yes. Yukio is correct, because if I flip the order of the triangles and go from big triangle to small triangle, I still have to use the corresponding sides. I'm going to say yes because I'm going to say I'm going to go backwards. I don't want to say AB. I want to say E or DE. Side DE is equal to, actually instead of equal to, I'm going to say corresponds with our little ratio right here. DE corresponds to AB. DE equals 3, AB equals 1. That would get us the ratio 3:1. Okay, now if you look at the next page in your book, let me flip my paper, you're going to see that I don't have it. Instead, I have the same piece of paper that I just did for some odd reason. But the next page in your book is number 7, and you'll see that it's green. Do you see the top? It says green and it has your name on top. That's your homework. So what you're going to do is you're going to tear it out and you are going to do your homework. Do both pages, back and the front, and then you are going to scan both pages and you are going to put them into the Google slide and then submit it in Google Classroom. Now, if you need any help with scanning, let me know, because I want you guys to get good at this for when it is time to do online learning. All right, guys, if you have any questions, always know you can come ask me. All right, bye-bye.